and y to mu, for example, are sigma finite measure spaces. Okay, if E belong to this sigma algebra, then this function is an S-measurable function on X, and this function is a tau-measurable function on Y. Please note that this is a function on X. X image to these exempted real numbers. We know that for any E in this tensor product, please note that okay. For any element in this sigma algebra, we know that Ex by our notation Ex, this cross section, okay, is an element of tau. And so we can be acted on this element because V is a function from tau in 0 infinity. Okay, please note that X is mu is a measure space, so that mu is a measure function from S to 0 infinity, and also y to mu is a measure space, so that mu from tau in 0 infinity is a function. This is a measure function. Okay, so that this is an element of tau, so that mu of this element is defined. Okay, Why section? Because EY is an element of S. Okay. Similar to this, for any E in this sigma algebra, we see that this is the sigma algebra on X times Y. Okay. Y is an element of S, so that mu of this element is defined. Okay. Mu of this, because this is an element of S, and mu can be acted on all element in S. So that this proposition says that if X is mu and Y 2 mu are sigma finite major spaces, for any element of this sigma algebra, these two functions are measurable. This function is a measurable function on X, and this function is two measurable function on Y. Okay, I omitted the proof of this proposition because it is slightly long, so that you must understand only this proposition without proof. Okay. In this definition, we express integration notation. Suppose X is mu is a measure space, and G from X to this interval is a function. The notation, the integral of G of X d mu of X means the integral of G d mu, where d mu of X indicate that variable other than X should be treated as constant, because please note that this G may be depend on other variable. Okay, but by this notation we consider only X as a variable moved and other variable be fixed. Okay. Yes. Do you have my voice? Okay. So that by this notation only we consider X as a variable and other variable considered constants. Please note that this example, if lambda is Lebesgue measure on this interval, then the integral of this function d lambda y equal to this, because if we write d lambda y, it means that this function must be considered as a function by this variable, and other ones consider as a constant. Okay, this is a constant, so that this integral x2 plus y this integral of x to the power of 2 plus y d lambda y in this interval 0 4 for example equal to x2 y plus y2 divided by 2. Okay, this 0 4 and this is equal to 4x to the power of 2 plus 4 to the power of 2 divided by 2, so that this is equal to 8. Okay, 16 divided by 2, so that we have this integral dy means that we consider y as this function variable, and this is play the role of constant, so that this integral dy equal to this. Okay, and if we consider this integral x to the power 2 plus y d lambda x, it means that this is as a constant and this is all variable, so that this is equal to x3 divided by 3 plus xy 0 4 and this is equal to 64 divided by 3 plus 4y. Okay, this so that we see that in this definition the integral gx d mu x means this, where d mu x indicate that variables other than x should be treated as constant. Okay, and we have this definition. Suppose x is mu and y to mu are major spaces, and f from x times y to r is function, then this integral means the integral of x of this integral, so that we must take at first this integral and then we take this integral with respect to mu by this variable. In the previous example, we see that we consider the integral of this function d lambda y, this is a function by the other variable x, so that we can take integral from this, or we take integral from this integral. Okay, the integral of this integral equal to this integral. Okay, and also other one, so that we must at first compute the value of this integral, and this is a function of variable x. Then we must take the integral of this function with respect to x. In other words, to compute this integral, first fix x in x and compute this integral dy, d mu y. If this integral makes sense, then compute the integral with respect to mu of the function x mapped to this integral, if this integral makes sense. If this integral makes sense and also this, we can compute this integral, and this is the definition of this notation. Example for this integral d lambda y d lambda x equal to integral x2 plus y d lambda y d lambda x equal to the integral of this integral, integral 0 4 x2 plus y d lambda y then d lambda x, so that we must compute at first this integral, and already we compute this, and this is equal to this function, so that this is equal to integral 0 4 this plus 8 d lambda x, and this is equal to, with respect to x, equal to, for example, 4 multiplied by x3 divided by 3 plus 8x 0 4, and this is equal to this multiplied by 4 to the power of 3 divided by 3 plus this. And if we compute this is equal to 352 divided by 3. Okay, and also we can compute this integral d lambda x d lambda y. d lambda x lambda y. This is equal to the integral of this at first then the integral of this function with respect to y, and we compute this as this function by variable y, so that we must compute this integral from 0 to 4, and this is equal to integral of this, and this is equal to this. We see that these two are equal. These two are equal. But this is not true. This is not true in, sorry, hello, سلام بو چه خبر؟ باشه فوتبال شروع نشد مگه؟ نه بابا من سر کلاسم با جواب دادم سر کلاس خدا I'm sorry. Suppose x is mu, y to mu are sigma finite measure space. If A belongs to S and B belongs to tau, then mu times nu of this rectangle by this definition equal to the integral of characteristic function on rectangle A times B d nu d mu. Characteristic function on this rectangle, and we see that this is equal to this. Okay, we see that this characteristic function equal to this or 0. We omitted 0 cases, and this as a constant can be moved x side of this integral, and this integral equal to mu of a, so that mu times mu okay mu times mu of this rectangle equal to this integral. Okay, this is our e. This is on x and y, d mu y, d mu x, and this is by definition equal to, this integral is on x and is on y. Okay, the integral of this function d mu y, then d mu x. Okay, and this is equal to, this integral is equal to this internal integral equal to this mu of b c of a on x. Okay, mu of b x. This is whole of this, because we can write this is equal to this 2. These two are equal. C of A times B equal to C of A, C of B. Okay. And this is a constant. Sorry, we must write this integral too. And this is a constant, so that we can exit this, so that we have this integral. Then du mu x, and this is equal to mu of b. This, sorry, this equal to this. D mu x. Now we can exit this. And this is equal to and finally this is equal to mu of b and mu of a, because this is equal to mu of a. Okay, finally we see that mu times mu of a times b equal to mu of a mu of b. Mu of b. Okay, is equal to this. This is an easy example for this definition, but this a definition for any in this tensor product, this sigma algebra. Mu times mu on E equal to this integral. And we have this proposition okay. Dear students, do you have my voice and image? Okay, thank you, Sajjad. Product of two measure in a measure. Suppose x is mu and y to mu are sigma finite measure spaces, then this product of measure is a measure on this measurable space x times y is tensor 2. We know that this is a sigma algebra on this set. Now in this proposition prove that this is a measure on this sigma algebra. So that in this proposition says that if x is mu and y to mu are measure spaces, then x times y is tensor 2 and mu is a measure space. This is a measure space, or this is a measure on this sigma algebra. This is a measure on this sigma algebra. Okay. Clearly, mu times nu of empty set equal to empty set, because for example we can see that mu times nu on empty set equal to this on empty times empty, because this is equal to empty set, and this is equal to mu of empty, nu of empty, and both of this equal to 0, so that this is equal to 0 by the previous proposition. Okay, we can consider A and B equal to empty set. Okay, now suppose this is a sequence or disjoint sequence in this sigma algebra. Then we see that mu times nu on this union equal to the integral of this on x d mu. By our definition, because mu times nu of any E equal to this. And this is equal to the section of this function on x. Let me remember the section of functions. Section of functions. Okay, for any f from x times y to r, and for any a in x and b in y, the cross sections function fa and fb defined by this: fa of y equal to f of a and x for any y in y, and fb of x equal to this. So that in the definition of mu times we knew In this definition, this is the section X function. Okay. For any E in this sigma algebra, mu time mu on E equal to this. Phi of E xy du mu y d mu x. Okay, and xy. We say that this is equal to this. X on x and y d mu y d mu x d mu x. Okay, this section function, it means that in this function we consider x as a fixed member. Okay, and we take integral on other variable. Okay, so that in this proposition, if we take this measure mu times mu of this union E k, for example, this is equal to integral phi of this union k from 1 up to the infinity x d mu y then d mu x. Okay, x and y. In this definition, we put this union instead of E, so that we must put this E as this union. And this is equal to this, because this is equal to this characteristic function. Okay, this is a cross section of set, and this is a cross section of functions. Okay, d mu y d mu x. this holds because we know that phi of any e x equal to phi of e x. Okay. Now, if we consider this inner integral, this is equal to nu of this set. Okay. So that this is equal to integral of x, then nu of this set then the mu x. It is not that this equal to this. This yellow parenthesis equal to this yellow. In general, the integral of phi of any f, for example, the mu equal to mu of f. Okay. If you consider this as a star and this is double star, is obtained by a star and this is obtained by double star, and this is equal to mu of this union E k section x. K from 1 up to the infinity d mu x, because we know that the cross section of this union equal to this union of cross sections. Okay, k from 1 up to the infinity, k from 1 up to the infinity. If we consider this as 3 star, this holds by 3 star. Okay. And now we reach to this equality and this equality, and this is equal to this because this nu is a measure and these sets are disjoint. Okay, so that this is equal to equal to this is equal to integral of x, this summation mu of ek of x k from 1 up to the infinity d mu x. And this is equal to this limit k from 1 up to the n mu of ek x and then to infinity d mu x, and this is equal to this limit by monotone convergence theorem. Okay, monotone convergence theorem. And this is equal to this limit, this is equal to this summation k from 1 up to the n integral of mu of ekx d mu x. And this is equal to this summation by the definition of summation. Okay, this is equal to this summation k from 1 up to the infinity integral of mu of ekx d mu x. And this is equal to integral of x, integral of y, ekx d mu by d mu x. And this holds again by this condition, for example 2 stars. Okay, 2 stars. This ek is equal to this by the definition of product measure. So that we see that mu of this union equal to this summation, so that this measure is countably additive on S tensor 2. We prove that this function is countably additive on this sigma algebra, okay? And also mu times nu of empty set equal to 0, so that this is the measure on this sigma algebra. So that this is a measure on this sigma algebra, and we prove our proposition. This is a measure on this, so that this is a measure space. Okay. Okay. We can continue in the following session. Dear students, do you have any questions? Dear students, do you have any questions? Dear students, do you have any questions? هل لديك أسئلة؟ Okay. Thank you very much, and thank you for your attention. We will continue in the next session, inshallah. Goodbye for now.